Hello there, welcome to my work solution to the question of the day, number 12. Every day for the past 12 days I've been posting a series of maths challenge questions on my Facebook page. Why not head over there to see the rest of them, or if you want to find out details about the tutoring services that I offer. So I've chosen this challenge question. I like it. I think I'm always drawn to questions that involve shapes, and this one I think has got a little bit of algebra in there, so I like it even more. So I've been told that the three rectangles below all have the same area, and what I've got to do is I've got to find the value of x add y. On one of my previous questions, I said that sometimes it's possible to just find the value of x add y rather than finding the individual values and adding them together. However, in this question, I may find that I have to find out the individual values and then sum them. So what I'm going to do first is I'm just going to label each of my rectangles A, B and C, where A, B and C correspond to the area of each of my rectangles. That means the area A must be xy, because of course the area of a rectangle is base times the height. Area B is whatever x add 4 multiplied by y minus 3 is. And if I expand that, I'm going to get xy minus 3x add 4y minus 12. And that's just expanding a pair of quadratic brackets. Now, since I know that those two areas are the same, therefore I can see that the value of the area for A must be the same as the value of the area for B. And that implies that xy must be equal to xy minus 3x add 4y minus 12. I'm just going to simply subtract xy from both sides. I want to keep the balance between the sides of my equation. And I can see that 0 must be equal to negative 3x add 4y minus 12. I think what I might do is I might just try and rearrange it so I can see that 3x subtract 4y is equal to negative 12. And then I have a simultaneous equation. I'm going to highlight that in blue. I'm linking the areas A and B together. Now, I could have linked area A and C together, so I think I might just do that. I'm just going to have to zoom out, I should say, slightly for this. So I'm just going to start with the fact that area A is xy again, and area C is x add 8 multiplied by y subtract 4. If I multiply those two brackets out, I get xy minus 4x add 8y minus 32. Now, again, I've got area xy, area of A, must be the same as the area of rectangle C. So I've now got another two expressions that I can make equal to each other. So this time I know that this implies that xy must be equal to xy, subtract 4x, add 8y, minus 32. I can do the same thing again, subtract xy from both sides, and I've got 0 is negative 4x, add 8y, subtract 32. I might just bring over my x and y onto the other side by adding 4x and subtracting 8y from both sides. It's an equation, so I have to do that. I don't move them. I've got 4x, subtract 8y, and I'm going to have negative 32. Lovely. So I've got a second equation. So I've now got two equations when I label them equation 1 and equation 2. And there's a number of ways I could solve these simultaneous equations. I think I'm going to start by writing them next to each other. That's equation 1, and the other one next to it is equation 2. Okay, now what I notice is that I have 8y in one of the equations and 4y in the other. If I was to multiply everything in equation 1 by 2, which means absolutely every single term in the equation has to get twice as big, I would have 6x minus 8y is equal to negative 24. And that means I've got two equations with negative 8y in. And there's a couple of different ways that I can solve these. I could rearrange this first equation to get 6x add 24 equals 8y. And I could rearrange the second equation by saying that 4x add 32 is equal to 8y. I notice that those two equations give me 8y, which therefore implies that 6x and 24 must be worth the same as 4x and 32. I've now just got this equation to solve, so I think I'm going to subtract 4x from both sides. So I'm going to get 2x add 24 is 32. And if I just subtract 24 from both sides, I get 2x is equal to 8. I can therefore see that x must be 4. Okay, good. Now let's find the value of y. So I've been told a number of things. I've got lots of different relationships here going on. I think I'm going to choose this one up here. I've got 4x and 32 is equal to 8y. I could simplify this if I wanted to, but I'm just going to literally substitute in what I've got. I've got 4 lots of 4 because, of course, x was equal to 4 add 32 is equal to 8y, which means I've got 16 add 32 is equal to 8y. Therefore, I know that 8y must be equal to 48 and y must equal 6. I think I had to find the value of x add y, which is 4 add 6, which is 10, and that's the answer. If I go back to the question, I think 10 was one of the options actually, and D was 10, which was the answer. I'm not saying that my way is the best way, I'm just telling you a way that I did this question. There are other ways of solving simultaneous equations that you might have used. There were other equations that you may well have built or simplified in order to solve them. I'm just showing you the way I've done it today, which may well be different to a way that I choose to do it on a different day, because that's maths. Okay guys, thanks very much for listening. Goodbye.